Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to solve a couple more logarithmic equations. They are similar except for the way each solution ends. So for the first one, I've got a logarithm of an expression equal to a number. I can start by changing that to exponential form by raising the base to the number on the other side of the equation. So 3 to the third power equals, and I'm going to go ahead and multiply out 4x plus 1 times x plus 1. That is 4x squared plus 4x, distributing the 4x through. And then I'll distribute the 1 through, plus x plus 1. Little cleaning up here, 3 cubed is 27, equals 4x squared plus 5x, combining some like terms, plus 1. And we'll subtract over the 27 to get it into standard form. 0 equals 4x squared plus 5x minus 26. So again, we've gone back to chapter 1. We've got a quadratic equation. I look at that, and if I can't factor this quickly, I'm going to apply the 5-second rule or the 10-second rule. If I can't factor it quickly, then I'm going to go ahead and use quadratic formula. I'm going to pretend that I couldn't factor this one, and I'm going to solve it with quadratic formula, but it does factor. Quadratic formula, x equals the opposite of b, so negative 5 plus or minus square root of b squared, so that's 5 squared, minus 4 times a, which is 4, times c, which is negative 26, all divided by 2 times 4. The inside the square root, the discriminant, 5 squared is 25. 4 times 26, there's 2 negatives there, so it's going to be an addition, right, a sum, plus. And if you multiply that out, you're going to get 416. So we've got negative 5 plus or minus square root of 25 plus 416, all divided by 8. 25 plus 416, that's 441. And when you take the square root of that, that's 21. When you can take the square root cleanly, that means that it could have been factored. But we've gone so far, we might as well finish with this. Negative 5 plus or minus 21 divided by 8. And we'll break that into two solutions. Negative 5 plus 21 divided by 8 is 16 divided by 8, or 2. The other solution, negative 5 minus 21 over 8, is negative 26 over 8, and that reduces to be negative 13/4. We need to make sure that the logarithm is of a positive number, and when you check it with the 2, coming back to the top, 4 times 2 plus 1 times 2 plus 1, you get 9 plus 3, or 27. If you do the same thing with negative 13/4, both expressions in parentheses are going to be negative, but when you multiply the negative times the negative, it's going to be positive 27 as well. So both of these solutions are okay, but you do need to check. By the way, if that had been written as the sum of two logarithms to begin with, right, log base 3 of 4x plus 1 plus log base 3 of x plus 1, the negative 13/4 wouldn't have worked, right? Both arguments would have been negative, but we didn't have that, so here they're both okay. Negative 13/4, comma 2. The other one, oh, and by the way, let me just say, I knew it factored. If we had been able to factor it, it would have been x minus 2 times 4x plus 13. And then we could have got our solutions directly from there. So if you can factor, the finishing steps are always faster. You just don't want to waste a lot of time trying to factor it. Problem 9, looks the same, but what's going to happen here, this one doesn't factor. The square root is not going to work out so cleanly. That's okay. I'm going to change it to exponential form. 2 to the third power equals, and I'm going to distribute again. 2x times x is 2x squared. 2x times 4, that's plus 8x. 3 times x, that's plus 3x. And finally, 3 times 4, that's plus 12. 2 to the third power equals 8. So to get this in standard form, I'm going to subtract the 8. I'm going to combine some like terms, and we get 0 equals 2x squared plus 11x plus 4. And that one does not factor. So we go to the quadratic formula. X equals the opposite of b, so that's negative 11, plus or minus square root of b squared, that's 11 squared, minus 4ac, that's minus 4 times 2 times 4, all over 2a, or 2 times 2. Inside the square root, 11 squared is 121, minus 4 times 2 times 4 is 32. That's 89. So we get x equals negative 11 plus or minus the square root of 89 divided by 4. 89 is prime, so we can't take the square root of that. And that means that we're going to get two exact solutions with square roots in them. Negative 11 plus square root 89 divided by 4. And negative 11 minus square root 89 divided by 4. But I do need approximate solutions because I still have to check the original equation. So I need some decimal values to plug back in. And if those decimal values give me a very low positive number, I need to make sure I've used enough places so that I don't have any doubt that it's going to be positive. Let's see. Let's go to the calculator for negative 11 plus or minus root 89 divided by 4. We'll start with a fraction. Negative 11 plus square root 89 all over 4. That is negative 0.392. For the other one, negative 11 minus root 89 over 4. That is negative 5.108. Make sure I haven't transposed anything. We're good. Okay. Now the check has to be into 2x plus 3 times x plus 4, and that product needs to be positive. So let's see, I'm going to check the first one here. 2 times negative 0.392 plus 3 times negative 0.392 plus 4 for x plus 4. And let's see what we get. The first number is 2.216, if I've done that right. 2 times that is negative 0.784. 3 minus 0.784 is 2.216. Yeah. And on the other side, negative 0.392 plus 4, that is 3.608. Multiplying a positive number by a positive number is good, and that answer should be close to 8 when we multiply them. For the other one, 2 times negative 5.108 plus 3 times negative 5.108 plus 4. Inside the first parentheses, that first product is negative 10.216 plus 3. That's negative 7.216. And on the other side, negative 5.108 plus 4, that's negative 1.108. Both of those are negative, but when we multiply them, it's going to be positive. and so that's going to work as well. That answer should also be close to 8. And the reason I keep saying it should be close to 8 is because I know that that's what 2 to the third power was. All right, so there's a couple of logarithms where we basically had the logarithm of a quadratic expression equal to a number, convert it to exponential form, factor if you can, quadratic formula if you have to. All right, we've got one more video solving log equations. I'll be back with that one in just a moment.